Today I'm going to be looking at a thing called bend radius. I'm going to be working with a piece of aluminium strip here, and I'm going to demonstrate why it's important to bend metal with a radius. This particular piece of aluminium strip that I've got here is very soft. It's in a non-hardened state, which means it's very easy to work, and lots of times aluminium alloys are produced in various states of hardness. The higher the hardness, the stiffer it is, the harder it is to work, and the trade-off is it can be easier to crack. I'm going to fold up this piece of aluminium strip just over here in the vise, and I'm going to demonstrate what happens when you don't use a radius to do a bend. What I'm going to do is I'm just going to put a 90-degree bend in this piece of aluminium just here using this vise. Now, if this was a piece of work that required structural strength, you would never bend it the way I am against a knurled edge like is on this vise. The knurled edge is really good for giving grip, but the bad side of it is it's going to put indentations into the metal, which will both mark the metal, but more importantly, affect its structural effectiveness. I'm just going to tighten this up here in the vise, and I'm just going to tweak using my thumb. Now, because this aluminium is in a non-hardened state, it's very easy to work. I don't need to put much force at all. There we have what looks like a nice sharp bend. However, if you look very closely at the edges of this bend here, there's actually a bunch of little white lines, and all of these lines are cracks. Each one of those cracks along that edge has now become a stress riser, and in any kind of load carrying situation, this piece of material is highly likely to crack and fail along that bent edge. When you look from a distance, that bend looks dull, and when you look up close, you can actually see the small minute tears and cracks in the work. On the inside of the bend, you can also see the little indentations that have been made by the knurls on the vise, and obviously in a load carrying situation where this was vibrating, this piece is likely to fail both from the inside and the outside here. So while it might look okay from a distance, if this was carrying any kind of structural load at all, this is highly likely to fail. In the situation that you're trying to bend up something and you want it to have a structural integrity, I've already mentioned that a bend radius will increase the structural integrity. I've talked about this in some of my SolidWorks videos where I discuss fillets as well. Fillets and radiuses are one of the best ways to spread a stress riser over a greater area, thereby reducing the chance of failure. If you're working with sheet metal, there's actually a formula and mathematics and stuff that can be done to calculate the correct bend radius for the material that you're using. It takes into account the angle of the bend, the thickness of the material, the type of material, how much tempering or hardening has been done to the material. All of those factors play into the calculation of a correct bend radius. Here in the garage though, all I have with me is a vise. I'm going to create a bend radius. Now, you already saw me create a sharp bend in the vise. Simply what I'm going to do is I'm going to use that piece, then I'm going to form the new bend around that material. That bend that I made just before is actually quite a good piece to form around. I'm going to position the work in the vise, and I'm going to use this little sacrificial piece of material here up against the work so that the knurls in the vise don't damage the material. It's probably an important note to add that if you were actually producing a bend for something structural, you would be far better off using a sheet metal brake or a brake press than bending with a hammer and a vise like I did just now. You can still get by with this kind of minimal setup. When you take a closer look at this bend as compared to the first one, you'll see the bend is showing much less signs of strain. In this case, the radius still wouldn't be sufficient to stop those micro tears from happening in the material. So if I were to take this piece and use it structurally, I would not have faith that it's going to last very long at all. Having said that, with an unhardened piece of aluminium, I wouldn't be expecting it to last a long time anyway, carrying any kind of load. Despite this second bend radius not being quite good enough, on close comparison of the two pieces of work, you can see the one that's been bent around a larger radius has much less fractures and tearing. Also, on the inside, you can see there's no marks from the vise. The first piece, however, shows lots of signs of cracks and micro tears, and the inside has definitely been damaged by the vise. So there you have it, a practical demonstration of bend radius and how you can form a radius in a bend at home using minimal tools and equipment. Until next time, see you later.